Hey environmental science students, we're going to learn about the rule of 70 today for population calculations. So you're going to see a problem like this, a few different problems, where it tells us a population growth rate, or in some of the later problems maybe show you how many years for a population to double. So this is a cool calculation to find doubling time of a population, where you just take the number 70 every time. This will always be the same, don't change it, and then divide it by the population growth rate. So in this case, divide it by 0.8. And then you're going to just calculate that 70 divided by 0.8. I'm going to do that to the side over here. And that's 87.5. So that is how many years it will be for the population to double. And we have a follow-up question about this, so let's look and see. It says, if the population size was 66 million people in the year 2008, in what year will the population have doubled, and what will be the new population size? So a couple of these things are given. 66 million is the original population size. So the new population size, we just multiply that by 2. It's doubling. So all of these are questions about doubling time. So we'll take that 66 times 2. So now 132 is the new population size. And the doubling time in years is what we just calculated at 87.5. I believe it'll be fine to round it to 88. And then the year the population doubles, we're going to add that to the starting year that was given to us. So you just do 2008 plus 87.5. Let's round that one to 88. And that would be in the year 2096. So quite some time from now. Let's see another example where we have instead the doubling time given to us. So this one, the doubling time is given, and we want to figure out the growth rate. And so we're going to find out a percent. So if it asks for population growth rate, you're going to look for that percent. But it's still the same calculation where up here, you're going to put 70 every time. And then here, instead of the growth rate, you're going to put the doubling time, 19. So 70 divided by 19. And that's 3.68%. So it's already going to be the percent when you calculate it. And doing the follow-up questions for this one, if the original population size was 31 million people in 2016, we would do times 2 to find the new population size, 62. And the doubling time is actually in this problem given to us up here, 19 years. And the year the population would double, we would take the given starting year, 2016, and add on that doubling time, 19 years. So 2016 plus 19 will equal 2035. And I just want to show you really quick the reason why this works. If you have a formula like this, 70 divided by the growth rate equals the doubling time, I'll just call it T. Then if time is what we're solving for, we would divide by rate. But if what we wanted to solve for was time instead, if you multiply both sides by r to get it out of the denominator over here, and then divide both sides by time, then you would end up having this as your formula. The rate is equal to 70 divided by the doubling time. So it works out to be really the same formula both ways.